Okay guys, so tonight our homework is S71, numbers 1 and 2, and that's a part of Module 5. So your stamp sheet should look like this. It's assignment number 2, S71, numbers 1 and 2. I just put the date here because it helps me keep track of if you're absent, what day you missed, and what the homework was that specific day. But you really don't need to put that there. But if it helps you, put it there. Okay, so your stamp sheet should look just like this. Okay, let's take a look at the homework. So I'm on page 71, S71 of Module 5. I'm going to read through the lesson summary and talk about things that are important when I look at this lesson summary. There are a few basic assumptions that are made when working with volume. The volume of a solid is always a number greater than or equal to 0. The volume of a unit cube is by definition 1 cubic unit. If two solids are identical, then their volumes are equal. If two solids have, at most, their boundaries in common, then their total volume can be calculated by adding the individual volumes together. Okay, so what I want you to really focus on right now is this first one. It talks about that the volume of a solid is always a number greater than or equal to 0. So when I think of volumes, I think of the amount of liquid in like a container. Like here, I have my hand sanitizer right here. And the volume is the amount of space inside. And I can't have a negative volume. So that's what it's saying when the volume of a solid is always a number greater than or equal to 0. So if it was 0, it would be an empty bottle. If it were more, then there would be hand sanitizer in that bottle. Okay? So a little recap on volume and what it means. Okay? So let's look at our first problem. Calculate the area of the 3-inch white border of the square figured below. So calculate the area, that's important, I'm going to underline that, of the 3-inch white border of the square below. Those are important because now I know what I'm calculating, what it looks like, so I know what to look for, and I know it's square, and I'll explain in just a second why that's important. So, well, I'll explain right now why it's important. So a square, we know, has all equal sides. That's what makes it a square. So I'm trying to calculate, I'm going to shade it, this white space all around. So you see that? It's like the frame of a picture frame. Okay, and then this shaded area would be the glass. I'm trying to calculate what the area is of all of this. So my first step is going to be to find the area of the outer rectangle, this whole rectangle, the big one, and then I'm going to subtract the area of the smaller square. I said rectangle, I meant square, I apologize. So when I look at this, I know that the smaller square is 11 inches on each side. And to find area, the formula for area is each side squared. So it would be 11 squared to find the area of the smaller square. But I'm trying to find the area of the larger square first. So if I look, I have 3 inches right here, 11 inches right here, and 3 inches right here. So if I do 11 plus 3, which is 11, 12, 13, 14, 15, 16, 17 inches, I know that if this length right here is 17 inches, then this whole length is 17 inches, because you can see those are totally equal. And it's a square, so I know that all sides are 17 inches. So I would do 17 squared. Area equals 17 squared, which is squared, remember, is just the number times itself. So 17 times 17, I could grab a calculator, but I'm not. I'm going to work it out. Long multiplication, since we've been working on that. 7 times 7 is 49. 7 times 1 is 7 plus 4, 8, 9, 10, 11. I'm going to put my 0 placeholder on my second story. 1 times 7 is 7. 1 times 1 is 1. I use my form and cross it out so I don't get confused. Add those together, I get 9, 8, 289. So my area of my large square is 289. I'm running out of space. So actually what I'm going to do is I'm going to write it over here. Large square equals 289 inches squared. That's how you write the area when we're talking about problems like this. Okay, so I have my large square. I know the area. I'm trying to find the area, again, of the border. So I need to find the area of the smaller square so I can subtract it to get just the border. Okay, so small square. It tells me that each side is 11 by 11. So I'm going to do 11 squared, 11 times 11. You know what? I'm going to work it out to make sure what I think it is right. 1 times 1 is 1. 1 times 1 is 1. My 0 on my second story, 1 times 1 is 1. 1 times 1 is 1. 121. Again, I'm running out of space. I apologize. Okay, so 121. So I'm going to make myself a note. Smaller square is 121 inches squared. So now, again, we're trying to find that white border. So if I subtract my larger square from my smaller square, I would be left with just the space I'm trying to find. So I'm going to do 289 minus 121. 9 minus 1 is 8. 8 minus 2 is 6. 2 minus 1 is 1. So 168 inches square. You guys, this is real life stuff. If you're remodeling, if you're trying to figure out the area so that you can buy new flooring, a lot of time in house projects, you have to know this kind of stuff. So really cool stuff because I'm telling you it's real life. I'm going to adjust so we can see number 2. Okay, because remember our homework's number 1 and 2. So this one, write a function that would allow you to calculate the area, A, usually area is always represented by A, of a 3-inch white border for any size square picture measured in inches. So let's look at this. It looks really familiar. 3-inch border, just like number 1. Oh, but it doesn't tell us what our inside dimensions are. So I'm going to use a variable to represent the unknown, and my variable is going to be S, stands for side. So it's the same thing. Our smaller square, the area of our smaller square that we don't know the dimensions for is just S squared. Okay, the dimensions of our larger one, I would add the length of a smaller side and then add 3 and 3, which is 6. So A equals S, that S, plus 6 on each side, 3 on each side, which is a total of 6 squared. So that's my smaller one. This is my larger one. And again, we're trying to find the border. Well, we know from up here that we take the larger area and subtract the smaller area. So I'm going to take my larger area and subtract my smaller. So just like this. That's a 2, not a Z. 2 minus S squared. That is your answer. We don't know what this side is, so we use a variable to represent it. And that's it. Again, guys, real life stuff. It's really exciting. This is getting us into geometry, which is pretty cool. So that is your homework for tonight.